Now, these poppies are what we would typically associate with the production of painkillers like morphine and, of course, heroin. But now a breakthrough in science has led to morphine being synthesised using the same kit used to make homemade beer. It is extraordinary. Well, they've done this by getting genetically modified yeast to convert sugar into the drug. But what does this mean for the future production of morphine? Could we see it more widely available to those who actually need it? Or is there a danger of a new illicit trade? Fascinating area. Let's find out more from Professor Paul Freeman, who's one of the directors for the Centre for Synthetic Biology and Innovation at Imperial College London. We also have Ann Fordham, Executive Director of the International Drug Policy Consortium. Thanks to both of you for joining us here. This is an absolutely fascinating area. We'll talk about issues and ethics in a moment. Professor, first of all, to you, just tell me a little more about the science of what they've done here.
I think it's a pretty transformative stage, actually, for what they've actually achieved, because they've filled in a sort of part of a puzzle which people have been working on for the last sort of 7 years, which is to try and take the genes that make morphine from poppy seeds and transplant them into a yeast cell, and then grow out yeast using glucose as the sort of main kind of source of energy and carbon, and then convert that glucose into these rather complex molecules that are found in plants.
I made the comparison with sort of homemade beer. I mean, conceptually, is it in the same sort of ballpark?
It's very difficult what they've achieved, I think it's fair to say. This is a technical barrier. It's not something that one could easily replicate. I think the idea of yeast is very evocative, because we use yeast to grow beer and bread, and so thinking about yeast to grow what are quite complex chemicals, painkillers and morphine and other illicit drugs, is actually quite an interesting debate which we're having, I guess.
And Fordham, I mean, there are obvious downsides. We'll get to that in a moment, but just take me through, I mean, the potential here for, I suppose, the developing world where access to these sorts of painkillers is still difficult, causing enormous problems. I mean, there is huge potential here. It is exciting, isn't it?
Yes, I suppose in some ways it is exciting. It's an incredible technological advancement, and in theory it could lead to morphine being able to be produced for the illicit market, being produced much cheaper than it currently is, because you wouldn't have to grow opium poppies and then convert that into morphine for the illicit market. But currently, the reason why the availability of morphine globally is so poor is not due to the fact that supply is limited. Actually, supply is greater than demand, even for illicit opiates.
So for a country like India, which struggles, those people who want to get access to morphine, who need it, they struggle to, you don't think it would be transformative per se? Other things would also have to happen.
Well, India is currently the biggest global producer of licit morphine, in fact. India produces 90% of the world's licit opium for the medical market. But what's really worrying and distressing is that within India, due to overly strict regulations on morphine, people in India don't have access to it. So, for example, there are about 1 million cancer patients in India who require morphine for chronic pain. The World Health Organization estimates that just 4% of that 1 million has access to morphine in India.
That's staggering. So they make it, but they export it.
They export all of it, almost, yes.
Professor, how much debate is there around the notion that this is genetically modified, that part of the equation? Does that cause problems?
No, I don't see any problems. I think this whole new field that's developing called synthetic biology, where we want to develop sustainable biomanufacturing processes and use yeast to produce molecules that we need, I think in my view, that's it's a very clear direction of travel. I think what's interesting from this perspective is that the ability to do it now is real, and so I think it's very apt to have these debates.
And we're just looking at the basic ingredients that they're using here, the science that you explained a moment or two ago. In terms of the potential, it's not just the cheaper drugs that we were talking about a moment ago, but the potential for new painkillers, for safer painkillers as well.
Absolutely, because extracting morphine from plants, that's what the plant makes, and that's what nature has provided us with. But by taking it and engineering it into a yeast cell, we'll be able to take that morphine molecule and add further biosynthetic steps and maybe change it into different types of drugs and more safer drugs, and it allows a whole variability of chemical space to be explored, which you can't really do in a poppy.
Ann Fordham, you have talked about the technological advances in terms of the production of drugs, how that makes drug laws powerless in a sense. What do you mean by that?
Well, I think, you know, this new development actually also, I mean, it provides, it's going to be a game changer for the global drug market, both for the illicit market, because potentially you wouldn't have to export morphine from India to Africa. You know, it might be easier to produce in Africa than African countries growing opium poppy themselves. But for the illicit market, potentially if, say, it was diverted to the illicit market and people could produce yeast, make heroin, say, for example, from yeast here in Europe, and then they wouldn't have to sort of go to the Afghan poppy market to get the raw opium for their heroin production. That would sort of change the dynamics in terms of supply countries, producer countries, transit routes. And for policymakers, they really need to do some scenario planning around what potentially this development could mean.
Like what? I mean, what sort of regulation is needed, given there's this whole illegal, the drug lords would be watching a story like this, if they didn't know it already, and thinking, wow, this is a whole new area we could launch into. Yeah.
I think the thing is, you know, the traditional law enforcement approaches aren't working very well as things currently are. So this kind of technological advancement, which is part of a trend, by the way, that we're
But how do you get ahead of stopping this becoming a new area?
Yeah, I'm not sure, because I feel like once a technology is out there, it's out there, isn't it? And there's a potential for it to be incredibly lucrative. So I think it's important that the scientists are engaging now to say, okay, what will regulation of this look like, and trying to get ahead of that curve.
I mean, it's fair to say that we don't have a yeast strain that can take glucose and make morphine yet. They've filled in a part of the puzzle. No one's actually put the whole thing together yet. So this is preempting the
Well, that's what I was going to come to just briefly and finally. I mean, I think it's 9 stages or whatever it is. The scientists now explained every single stage. It's about bringing all of that together. Do you anticipate in your lifetime they'll be able to do that?
Absolutely no doubt about that. But I think it's really good to have this debate now when we don't actually have it, because we can start thinking about the scenarios and what ifs and all the rest of it. And that's kind of what synthetic biology is trying to be very responsible about in terms of the development of this new technology.
Well, it is a fascinating area. Professor Paul Freeman, Ann Fordham, thank you so much for coming in and discussing it with us. Thank you.
Thank you.